So if we come up and look at this image, first of all, it's really gorgeous, and it's teeming with galaxies. And that's something that has been true for every image we've gotten with Webb. We can't take blank sky. Everywhere we look, there's galaxies everywhere. And so, this image, as we're looking at it, what we're seeing is not just all the galaxies, but there's a cluster here.
The James Webb Space Telescope, JWST, humanity's most advanced eye on the cosmos, has captured something extraordinary, evidence that shatters the boundaries of current physics. Instead of chaotic, dim galaxies slowly forming after the Big Bang, JWST is revealing massive, mature galaxies that seemingly shouldn't exist so early in cosmic history. This isn't just another astronomical milestone. It might be the first glimpse of another universe, or a reality we never imagined. Are we witnessing the breakdown of modern cosmology? But before we unveil the answer, subscribe to UFO Universe for more discoveries that challenge everything we know. Don't miss what could change our view of the cosmos forever. Launched in December 2021, the James Webb Space Telescope, JWST, was built to explore the early universe, peering back over 13 billion years to witness the formation of the first stars and galaxies. Its infrared vision allows it to detect light stretched by the universe's expansion, making it uniquely suited for this task. NASA's mission was ambitious: to understand how the first cosmic structures emerged from the darkness. Yet what the James Webb Space Telescope found left the scientific community, even Nobel Prize-winning scientists, in awe and confusion. The cosmos has always been a place of mystery, but recent discoveries have pushed the boundaries of what scientists thought was possible. Instead of the expected void, astronomers have detected bright, massive celestial bodies in regions where darkness should reign. Within these newly emerging galaxies, vast clouds of gas and dust swirl, heated by the violent collisions between these cosmic giants. Even more astonishing, structures appear to be forming at a pace that defies the known laws of physics, suggesting that the early universe may have operated under entirely different principles than those we understand today. This revelation raises profound questions. Are we witnessing the remnants of another universe, one that existed before our own? Or could we be standing at the precipice of a grand cosmic illusion, where reality is far more complex than we ever imagined? What lies beyond this enigmatic veil may not only redefine astronomy, but could fundamentally alter our understanding of existence itself. The idea of a universe that, by all accounts, should not exist, is both thrilling and unsettling. When the James Webb Space Telescope first began transmitting its deep field images, scientists anticipated faint traces of the earliest galaxies, slowly assembling in the aftermath of the Big Bang. Instead, they were met with something entirely unexpected. Scientists anticipated detecting faint signals from the first galaxies, gradually forming after the Big Bang. Instead, they encountered something extraordinary: bright, well-structured galaxies that defied expectations. One particular yellow blob caught their attention. Initially, researchers assumed it must be relatively close, as its brightness and sheer mass made it unlikely to be from the early universe. The prevailing understanding suggested that a universe only a few 100 million years old simply wouldn't have had the time to construct such a colossal structure. Then came the spectroscopic analysis, the definitive test. The results were nothing short of astonishing. That luminous entity was not a nearby anomaly. It was in fact one of the most distant galaxies ever observed. Its light had travelled for more than 13 billion years to reach Earth, offering a glimpse into the universe's infancy. Even more remarkably, this galaxy was not alone. The cosmos was teeming with similar, unexpected formations, challenging everything scientists thought they knew about the early universe. In the earliest images captured by the James Webb Space Telescope, JWST, astronomers were astonished to find a recurring pattern: luminous, well-formed galaxies scattered across the cosmos, like seeds sown in a celestial garden. These radiant structures stood in stark contrast to what scientists had anticipated: Rather than appearing as faint, disordered, and underdeveloped, as predicted by prevailing cosmological models, these galaxies were dense, star-rich, and surprisingly mature. Their organized appearance suggested a level of cosmic evolution that should have taken billions of years, yet they existed in a universe still in its infancy. It was as though the cosmos had somehow skipped ahead in its developmental timeline, accelerating through its formative stages at an inexplicable pace. This unexpected discovery sparked a profound and urgent question. How could such massive, structured galaxies have formed so soon after the Big Bang? The process of galaxy formation, as we understand it, requires a sequence of events. Gas and dust must accumulate, collapse under gravity, and ignite into stars. This sequence is thought to unfold over vast stretches of time. Yet, the early universe, only a few 100 million years old, seemingly lacked the temporal allowance for such complexity. Initially, some scientists speculated whether the telescope's instruments might be flawed or if the data had been misinterpreted. However, as similar results emerged across multiple observations and were corroborated by independent research teams, it became clear that this was no error. It was a genuine cosmic enigma. Thus, a question as old as humanity itself resurfaced with renewed urgency and complexity. How did we come to be? If these galaxies are indeed real, and the mounting evidence strongly supports their authenticity, then the early universe was operating in ways that current scientific theories cannot yet explain. This revelation suggests that our understanding of the cosmos may be incomplete, and that the universe, in its earliest moments, may have followed rules or dynamics that remain hidden from us today. Nevertheless, the foundations of modern cosmology are beginning to show signs of strain. For many years, the lambda-CDM model has served as the dominant theoretical framework for understanding the universe. This model posits that the cosmos is primarily composed of cold, dark matter and is being driven apart by the mysterious force of dark energy. It has successfully accounted for the formation of galaxies, the large-scale structure of the universe, and the accelerating expansion of space. Until recently, it was considered nearly unassailable. However, the James Webb Space Telescope, JWST, has begun to challenge this long-standing paradigm. Its observations have revealed galaxies that are not merely unusual, they are far too massive, too luminous, and appeared far too early in cosmic history to be explained by current theory. Under the lambda-CDM model, the early universe should not have had sufficient time or raw material to produce such enormous and well-formed galaxies so soon after the Big Bang. The theoretical calculations no longer align with the observational data, the energy equations falter, the timelines collapse, and the entire structure of the model begins to unravel. For galaxies of that scale to emerge within just a few 100 million years would require nearly all the available baryonic matter, primarily hydrogen and helium left over from the Big Bang, to be transformed into stars at an extraordinarily rapid pace. Yet, according to our best simulations and observations, such a rapid conversion is not only improbable, but physically implausible. Even in the most intense star-forming regions we've studied, the process remains sluggish and inefficient. Nature, it seems, prefers a more measured pace. In response, some scientists have attempted to modify the model by tweaking variables such as the star formation rate or the initial density of matter. However, these adjustments demand such extreme values that they end up destabilizing other well-established aspects of the model. It's akin to patching a hole in one part of a garment, only to cause a larger tear elsewhere. The result is a growing realization that the lambda-CDM model, while once robust, may no longer be sufficient to explain the universe in light of the new data provided by the James Webb Space Telescope. Not only that, the issue at hand is not merely a matter of measurement errors, it is a fundamental problem with the underlying framework itself. Even Nobel Prize-winning physicists have begun to acknowledge the growing inconsistencies within our current cosmological models. Some researchers speculate that dark matter may have exhibited entirely different properties in the early universe, behaving in ways that challenge long-standing assumptions. Others suggest that we may need to introduce entirely new physics concepts, ideas that have yet to be conceived or tested. One particularly bold hypothesis gaining traction is that the objects observed by the James Webb Space Telescope, JWST, may not be early galaxies at all. Instead, they could represent something entirely different, something beyond our current understanding of cosmic evolution. If the foundational model collapses at the very beginning of the universe's timeline, then every subsequent theory built upon it becomes unstable. And if our most established scientific frameworks fail to account for what JWST is revealing, we may be on the brink of a scientific revolution, one that could force us to rewrite the story of the cosmos from its very first chapter. The question remains, are these truly galaxies, or are they something else entirely? Initially, astronomers assumed that JWST had simply detected early galaxies that had somehow formed at an unexpectedly rapid pace. However, as more data continued to emerge, that explanation began to unravel, leaving scientists with more questions than answers.
Recently, we got a look at some captivating images as Webb peers back toward the origin of everything.
These galaxies weren't just forming rapidly, they were fundamentally different. They exhibited behaviors unlike anything observed in galaxies before. One of the most perplexing discoveries came through spectroscopy, a tool that analyzes light to determine an object's composition. It revealed that some of these early galaxies had converted all their gas into stars, an unprecedented phenomenon. In modern galaxies, only about 10% of the gas transforms into stars, with the rest remaining in clouds, awaiting gravity and time. But these ancient galaxies were fully formed, leaving no gas behind, just pure starlight. This finding stunned astronomers. When a galaxy uses up all its gas to form stars, it can no longer grow and burns out quickly. This also points to an extraordinary level of efficiency that contradicts every known theory of galaxy formation. According to our understanding of physics, this shouldn't be possible. However, there they are, shining defiantly from the edge of the universe. Several scientists started to voice a question that many were hesitant to ask. What if these objects are not galaxies at all? Perhaps they represent an entirely new class of celestial phenomena, something never before identified or categorized. Some researchers speculate that they could be massive star clusters, ancient quasars, or even remnants of a universe that predates the Big Bang. Others propose that these enigmatic structures belong to a category of cosmic entities so unfamiliar that we have yet to name them, simply because nothing like them has ever been observed. Adding to the mystery, these objects fail to exhibit the expected characteristics of galaxies. They do not rotate in the familiar manner, nor do they conform to the typical spiral or elliptical formations seen in known galactic structures. Instead, they appear compact, irregular, and unusually luminous, resembling cosmic fossils from a reality that perhaps was never meant to be witnessed. If these objects are not galaxies, then the implications are profound. Our entire understanding of cosmic history is built upon the assumption that galaxies serve as the fundamental building blocks of the universe. But if that assumption is incorrect, then we must ask, what exactly are these objects? Regardless of their true nature, one undeniable truth emerges. The universe is far more mysterious than we ever imagined. The discoveries made by the James Webb Space Telescope, JWST, may have just unveiled a chapter of cosmic history that does not fit within the framework of our current understanding. If these findings hold, they could force us to rethink the very origins and evolution of the cosmos, opening the door to possibilities that were once considered beyond the realm of science fiction. Before we continue to move to another part of today's video, don't forget to support us by subscribing to our channel. Thanks a bunch. When we gaze into the vast expanse of the sky, we are not merely observing space, we are witnessing time itself unfold. Every star, every galaxy, serves as a luminous marker of a different era in the universe's grand narrative. The farther we peer into the cosmos, the older the light we receive, offering us a glimpse into the distant past. Thanks to the James Webb Space Telescope, JWST, humanity is now able to probe deeper into the universe than ever before, uncovering celestial phenomena that were previously beyond our reach. However, there exists a fundamental boundary to our cosmic vision, known as the observable universe. This immense sphere, centered on Earth, spans approximately 92 billion light-years across. Beyond this limit, we are unable to perceive anything, not because nothing exists beyond it, but simply because the light from those distant regions has not had sufficient time to reach us. Yet, this is where things become truly perplexing. As the universe continues to expand at an accelerating rate, distant galaxies are receding from us at speeds exceeding that of light. According to conventional logic, their light should never be able to reach us. However, due to the peculiar nature of cosmic expansion, some of that light still manages to find its way to Earth. This phenomenon can be likened to watching a balloon inflate, with points on its surface rapidly drifting apart, while light bends and curves along the way. Contrary to the notion of an empty void, space is far more crowded and dynamic than one might assume. Galaxies frequently interact with one another, and over time, they even merge together, forming larger structures. This ever-expanding cosmic bubble is referred to as the Hubble sphere. Galaxies positioned beyond this sphere move away at speeds surpassing the speed of light. Yet, as the sphere itself continues to grow, it gradually captures more of the escaping light, allowing us to observe galaxies that would otherwise seem unreachable. This paradoxical interplay between expansion and observation challenges our understanding of the universe and underscores the profound mysteries that still await discovery. On the other hand, there exists a fundamental boundary in the cosmos that we can never surpass: the cosmic horizon. Beyond this limit, no light, no information can ever reach us, regardless of how much time passes. However, the inability to observe beyond this horizon does not imply that nothing exists there. In fact, most cosmologists strongly believe that the universe extends far beyond what we can currently detect, possibly stretching into infinity. If the universe is truly infinite, this realization would profoundly alter our understanding of reality. A common misconception is that the Big Bang was a singular explosion occurring at a specific point in space. In truth, it was an expansion of space itself, unfolding simultaneously everywhere. This means that the birth of the universe did not originate from a single location, but instead happened universally, even in regions far beyond what we will ever be able to observe. Consequently, when we gaze at the edge of the observable universe, we are not witnessing the end of space itself. We are merely confronting the limits of human perception. What lies beyond this boundary remains unknown, but some theories suggest it could be an entirely different universe. The relationship between time, space, and the origins of the cosmos is often misunderstood. Many imagine the Big Bang as a colossal explosion, violently propelling matter outward from a single point. However, this depiction is inaccurate. The reality is far more complex, involving the rapid expansion of space itself, rather than a conventional explosion. This distinction is crucial in understanding the true nature of the universe's formation and its ongoing evolution. If the universe is truly infinite, as many scientists theorize, then it must have always been infinite without a defined starting point or boundary. The Big Bang was not an explosion occurring at a specific location. Rather, it was the expansion of space itself, unfolding everywhere simultaneously. This means that the beginning of time did not establish a central point, but instead marked a moment that occurred universally, encompassing even the most distant regions beyond the observable boundary. Remarkably, the light from that moment still permeates our sky today, known as the cosmic microwave background, CMB, the lingering afterglow of the universe's first illumination. radiating across all directions. Yet, what if our fundamental understanding of time is flawed? Observations indicate that certain celestial objects had already formed stars a mere 200 million years after the Big Bang, which challenges the conventional timeline we have constructed. Could it be that time in the early universe operated differently than it does today? Or perhaps these objects were never part of the beginning at all? Some scientists propose that under extreme cosmic conditions, our conventional notions of before and after may break down entirely. In those primordial moments, the physical laws we rely on, gravity, motion, and even the behavior of light might not have functioned in the same way. This leads to an intriguing possibility. The early universe may not have had a true beginning in the way we traditionally conceive it. What we perceive as the start could instead be a transition from something else, something timeless, or something beyond our current imagination. If the Big Bang was not a singular birth event, but rather a phase shift, then it is conceivable that other phases preceded it, perhaps even other realities or universes. This realization forces us to confront a profound question. What truly happened at the dawn of existence? And if time itself has no definitive beginning, what implications does that hold for our understanding of the universe, and for us as observers within it? Next up, a recent study published in the Astrophysical Journal has unveiled findings that have left astronomers and physicists alike in a state of awe. Leveraging the extraordinary capabilities of the James Webb Space Telescope, JWST, researchers identified 87 galaxies that may have existed as early as 200 to 400 million years after the Big Bang. Even more astonishing, JWST has also detected galaxies that appear to have formed just 500 million years post-Big Bang. This discovery is not merely surprising, it borders on the impossible, at least when measured against our current scientific models. According to established theories, galaxies require significant time to develop. The process begins with vast clouds of gas collapsing under gravity, leading to the ignition of stars. These stars then group into clusters, which eventually evolve into galaxies. This entire sequence is believed to span hundreds of millions of years. Yet, the galaxies observed by JWST seem to have emerged in what feels like the blink of a cosmic eye. It's akin to flipping open a history book and finding fully developed cities already constructed on the very first page. What deepens the mystery is the remarkable structure of these galaxies. They are not chaotic or partially formed as one might expect from such an early epoch. Instead, they exhibit clear organization, significant brightness, and substantial mass features scientists had only anticipated seeing billions of years into the universe's evolution. If even a small fraction of these galaxies are verified as genuine, it would suggest that our foundational understanding of galaxy formation is fundamentally flawed and in need of serious revision. One of the principal scientists, astronomer Haojing Yan, expressed the situation with striking clarity. Even the confirmation of just a few of these galaxies would compel scientists to reconsider the established timeline of the early universe. These celestial bodies appear far too developed, too complete, for the brief period in which they supposedly formed. Some of them possess significantly more mass than should be feasible within such a short cosmic window. Others exhibit star formation rates that defy the foundational principles of cosmic evolution. Collectively, they present not just an oddity, but a profound new mystery, a gathering of ancient structures that, by all current models, should not exist. This is no longer an isolated anomaly. It has become a recurring pattern, and with every new deep-field image captured by the James Webb Space Telescope, JWST, more of these puzzling objects continue to emerge. These galaxies, or perhaps entities of an entirely different nature, are sending a message from the most distant and ancient corners of the cosmos. That message is unmistakable. Our current understanding of the universe is fundamentally flawed. The cosmic clock we've relied on may be miscalibrated, or worse, broken altogether. So, what path do we take now? Faced with discoveries that defy every known theory, the scientific community stands at a pivotal crossroads. Should we attempt to revise and patch our existing models to accommodate these findings? Or must we confront the possibility that something deeply fundamental is missing from our comprehension of the cosmos? Some researchers are already advocating for bold, paradigm-shifting ideas. Perhaps dark matter is not as inert as previously believed. Maybe the laws of physics themselves behave differently under extreme cosmic conditions. Meanwhile, even more radical theories are beginning to surface. Some propose a variable speed of light, while others suggest that primordial black holes may have seeded the formation of galaxies. There are even hypotheses involving quantum scale effects influencing the structure of the universe on a grand scale. Each of these theories attempts to make sense of what we're observing, but so far, none can fully account for all the evidence. The most daring idea is also the hardest to dismiss. What if these objects don't belong to the universe as we currently understand it? What if they are evidence of another universe, a separate reality interwoven with ours through some mysterious mechanism? If the multiverse exists, these brilliant early structures might be remnants of a neighbouring cosmos seeping into our own. Naturally, these are just hypotheses, speculations based on data we are only beginning to analyse. However, this is how science progresses, by challenging our assumptions and venturing into the unknown. Some scientists remain cautious, urging restraint and emphasising that extraordinary claims require extraordinary evidence. They are absolutely correct. However, that evidence is gradually accumulating, one discovery at a time. The James Webb Space Telescope was specifically designed to observe the universe's first light, to uncover the earliest stars and galaxies born in the infancy of the cosmos. Instead, it might be revealing the boundary of something far more profound. This isn't just about revising textbooks. It could mean redefining reality itself. So, what comes next? We continue to observe, we question everything, and we brace ourselves for answers that may seem more like science fiction than science. Because when the universe speaks, we must be ready to listen. To summarize, we started to see into the farthest reaches of the cosmos, and, instead of definitive answers, we've uncovered even deeper questions. The James Webb Space Telescope, JWST, has done more than simply reveal distant stars. It has exposed a profound cosmic puzzle that could fundamentally reshape how we view our place in the universe. We're seeing galaxies that appear to have formed far too quickly, encountering objects that defy current explanation, and confronting a timeline that no longer seems to align with established theories. Even the most brilliant, Nobel-recognized scientists are left in awe and uncertainty. Are we truly witnessing the dawn of time, or could it be something entirely different? Could this be evidence of another universe, or perhaps a deeper truth we've yet to comprehend? Whatever the answer may be, one thing is certain: we are only at the very beginning of grasping what these discoveries mean. And as we continue to gaze into the vast, unending darkness of space, one realization becomes unmistakably clear. This cosmic mystery is far from being solved. Last but not least, what do you think about this discovery of the James Webb Space Telescope? Don't hesitate to share your thoughts in the comment section below. And this is the end of today's episode, and we truly appreciate you being here. If the stories, evidence, or theories you heard today made you think twice about life beyond Earth, please like the video and subscribe to the UFO Universe channel. We have more incredible investigations and discoveries coming soon. Don't miss out. Join the growing community of truth seekers.